Hello, hello everyone. So today we will be solving this question called the shift plus escape from the recent Codeforces Division 2 round, and I definitely recommend to try this question on your own. And okay, here's the solution. So uh, instead of reading the question, I think, okay, it's better to read the question. Okay, so you are given a grid with n rows and m columns, and if you want to skip the problem intro, there are timestamps in the description. Okay, so you are given a grid with n rows and n columns of non-negative integers and an integer k. Let I comma j denote the cell in the ith row from the top and the jth column from the left. Okay, that's the classical definition of aij. And for every cell I comma j, the integer aij is written on the cell I comma j. Then you are initially at 1 comma 1 and want to go to n comma m, so you may only move only down or right. Okay, so that is, if you are at I comma j, you can only move to I plus 1 comma j or I comma j plus 1 if the corresponding cell exists. Now before you begin moving, you may do the following operation any number of times. So choose any integer I between 1 to n and cyclically shift row I to the left by 1. So formally simultaneously set aij to ai comma j mod m plus 1 for all integer j which are from 1 to m. So basically you want to set aij to ai j mod m plus 1. So what you need to do is that this is your aij, this is your, so basically suppose this is ai1, ai2, ai3, so on up to aim minus 1 and aim. So for every j from 1 to m, you are shifting it one step or one cell towards the left, and you are moving this first element to the rightmost cell. Okay, so basically aim will be set to, means this element will be set to ai comma m mod m, which will be 0. Okay, m mod m, which will be 0 plus 1, right? 0 plus 1 is 1. So aim will be set to ai1. So this element moves to the rightmost position and every other element shift towards left by one cell. Okay, that is how operation is working, right? Okay, so note that you may not do any operation after you start moving. Okay, so we have to do the operations whatever we want to do before we start moving from 1 comma 1 to n comma m by only two possible directions, right and down. And after moving from 1 comma 1 to n comma m, let x be the number of operations you have performed before moving, and let y be the sum of the integers written on the visited cells including 1 comma 1 and n comma m. Then the cost is defined by kx plus y, and now we have to find the minimum cost to move from 1 comma 1 to n comma m. Okay, so I think statement is self-explanatory. Let us take a look at the sample test case. Okay, real solution begins. Okay, so this is basically your grid. Okay, so this is kind of deformed, so let me sketch it again. So n is equal to 3, m is equal to 3, k is equal to 100. Okay, so I have sketched it, and Now what we can notice here is that to move from cell 1 comma 1 to n comma m, which is 3 comma 3 here, minimum number of what you can say, minimum cost, which is defined by kx plus y, where y is the sum of the numbers on the path, and k times x is the number of operations you will do on any rows or any number of rows. K is the total number of operations and k is basically the input parameter. Here k is equal to 100. Okay, so here what I will do is that I will perform one operation on this third row. So what will my third row become? It will become 101, 101 and 0. Okay, and after doing one operation, this kx will be 100 plus. Now I will trace this path. Okay, so right, down, right and down. Now what is the sum of the values which appear on the path? So 3 plus 2, 5 plus 8, 13. And this 0 is just null. Then it is 113. Okay, 113. So that is basically the minimum cost that you can get. Okay, you can try performing the different number of operations on a row, but you'll notice that this is kind of what you can say, the minimum that we can achieve. Okay, so let's go forward. And one more thing to notice here is that, so if I perform m number of operations on, suppose, any of the row, if I perform m number of the operations on the any row, then it is basically I'm doing nothing, right? I'm just increasing my cost for no reason. So what I can notice is that the number of operations performed on any row will range from 0 to m minus 1, right? Because if you want to shift it k time or m times, then basically you are not changing the row. Okay, you will end up having the same row as without doing any operation. Okay, so this is one key point to note here, that you will only rotate any of the row. If you want to rotate it, you will rotate it from 0 to m minus 1 times. Okay, okay, cool. And suppose, okay, so you can already notice that greedy solution won't work here, right? Greedy solution won't work here because there are many possibilities. There are many possibilities and you have to check every one of those, right? You don't know by your intuition that which path will lead to the minimum cost, right? So you have to check each and every possibility. So looking at the constraints, so n and m is are up to 200. So basically they are giving us freedom to write o of what you can say o of n cube or o of m cube or o of n m square or o of m n square type of solutions. So they are allowing us to write o of n power a into m power b kind of solution where a plus b is less than or equal to 3. Okay, okay, so the thing that comes to your mind when you see this many possibilities is that DP, right? Dynamic programming. So you want to check each and every possibility. So one thing comes to your mind, which is dynamic programming. Okay, how to apply dynamic programming here? So suppose this is my cell, any cell, okay? Suppose cell I comma j. This cell is I comma j. All right. So how can I come to this cell? So basically I can move down by the upper cell So I will perform this operation, or I will come right from the its left cell. Okay, so this way. So there are only two ways such that I can attain this state I comma j, right? So suppose answer of I comma j. Okay, so answer of I comma j will denote, okay, let us directly name it dp. So dp of I comma j will denote minimum cost required to make it to the make it to the cell I comma j. Okay, makes sense? I think it does. Okay, so I think this makes sense. Yes. And dp of I comma j is minimum cost required to make it to the cell I comma j. Okay, so how can I do the transition? Okay, so one important thing in the DP, dynamic programming, is the transition, right? So the most important thing in DP, I would say. Okay, okay, so DP of, suppose DP of I comma J. Okay, so how can I write this? So you will say DP of I minus 1 J. Okay, minimum of, okay, wait. So you'll say that it is basically the minimum of dp of I minus 1 comma j and dp of I comma j minus 1 plus the input matrix of I comma j. But will it work? Let us take a look. So problem is not that simple. Okay, so why are the rotations given? What is the help of rotation in minimizing our answer? So this won't work because suppose I will give you a counter example. So consider this grid. And here suppose some big number 100. Okay, and k is equal to be 2 here. Okay, so I can notice here is that dp of 3 comma 2. So basically to reach this cell is 1 plus 1 plus 1 plus 1, 4, right? And similarly dp of 2 comma 3. So basically minimum number cost required to reach this cell is also 4. But if you calculate dp of 3 comma 3 by this formula, then you basically get 104, right? But if I do perform one operation on this third row, okay, so it will become 111, 111 and 101. Now you can notice here is that, so I can come by this path and my dp of 3 comma 3. So basically my answer will be 5. So which is basically much less than this approach, right? So this formula won't work. But as we know that we have to come from the I minus 1 comma j or the I comma j minus 1, right? So we can only come from these these cells, right? So uh, so these type of things, the parameters I minus 1 comma j and I comma j minus 1 will appear in the dp transitions. But how can we modify the dp transitions? So let us take a look. So let me copy this down. Okay, doesn't copy well. Oh, this will also not work. Okay, so let us try to fit the rotation analogy or the rotation optimization in our DP. Okay, so what I will try to initialize is that I will try to write dp of I comma j comma x. Okay, so what will this denote? So this will denote the minimum cost it requires, to go to or get to cell I comma j when when the ith row is, okay, when the x operations, so when the x operations performed on the ith row. Okay, so here in the previous example, now you would notice that your dp of 3 comma 3 comma 0, it would be 104, basically after performing 0 operations on that row. Now your dp of 3 comma 3 comma 1 would have been 5. What about dp of 3 comma 3 comma 2? This will again be 5. Okay, so this 100 will just shift to the left and this one will go to the end. Okay, so you don't want to perform m or more operations, so we will halt at 2, and my answer will be the maximum over dp of n comma m, and third argument will be x. So for all x from 0 to m minus 1 integral x, so my answer is maximum of dp of n comma m comma x. So this way I will try to formulate my dp. So here our space complexity would be O of n cube, you would say. So this is basically fine, right? We can do that, right? So here we have saw it. So time and space complexity are okay to be like this, right? So yep, let's proceed to the, what you can say, the transitions in the dp. Okay, so let me draw again that cell I comma j. This cell is I minus 1 comma j, and this cell is I comma j minus 1. Okay, so if you want to go here, so you will try to come from the, so let's take a case where you are coming from the upside. Okay, so dp of, okay, let's be consistent with the colors, dp of I comma j comma x, this will be minimum of, so this will be minimum of dp of I minus 1 j. Okay, so I will define two dp's here. How two dp's? So first dp, which will be dp1, which will be three dimensional. Okay, which will be three dimensional, and my dp2, oh okay, not dp2, just let's take it as dp. My dp will be two dimensional, and the definition of my 2 dp two dimensional dp will be such that dp of I comma j is equal to minimum over dp1 of I comma j comma x for all x belonging to 0 to n minus 1. Okay, so, makes sense. So basically my answer will be, finally my answer will be dp of n comma m. I have to do nothing with the dp1 while calculating, while outputting the answer. I will just consider the value of from this dp two dimensional dp. So why two dimensional dp? So while calculating this dp of I comma j comma x, so listen, why two dp's are needed? So while calculating this dp of I comma j comma x, okay, while calculating this dp of I comma j comma x, listen carefully. When you are coming from the upwards cell, okay, basically when you are coming from the upwards cell, so this cell, then you don't care how many row operations, so how many operations were performed in on this block or this row. You don't care about the operations performed on the row I minus 1, right? So you just want the minimum value present here, minimum value present here to reach that cell. I don't care about how many or how the operations on the row I minus 1 are performed. I just care the minimum of those are dp1 of I, j, x, I minus 1, j and x over this row, right? So for that dp will take care, our dp will take care. And here, listen carefully. So now here, when you are coming from I comma j minus 1, okay, so when you are coming from I comma j minus 1, so you are coming, so when you are coming from I comma j minus 1, your answer depends on the rotations as well. So your answer depends on the number of rotations as well. Okay, so just like this is independent of just like this thing, I minus 1 comma j is there has to be nothing to be improved in this cell, because we are calculating the answer for this cell. Okay, when we are calculating answer for this cell, we don't have to care about this I minus 1 comma j, right? But we have to care about this cell, right? So what how I have to care for that row means, so basically most important part here is that, so dp of I comma j minus 1, so wait, so what I'm trying to say is that, so when you are trying to calculate the answer for this cell I comma j after performing the x operations, it may happen that your dp1 of I comma j minus 1 comma x is not your optimum answer. It is, it may happen that it is not your dp of I comma j minus 1, right? It may happen that it is not equal to dp of I comma j minus 1. Okay, but we know that we don't care about the rotations on the I minus 1th row, right? We don't care about them, but we definitely care about the rotations on the ith array, ith row. Okay, so this is why we need the 3D DP. Okay, so you will see here in the transitions what I'm going to write. So dp of I minus 1 comma j plus, okay, plus k times x, right? So you have performed the x operations on the, what you can say, the ith row. For that, k star x, so you are coming from above, and after performing this number of x number of operations on that row. And if you are coming from the left, if you are coming from the left, it is basically dp of I comma j minus 1 comma x, and this whole thing added with input of I comma j plus x percentage m. Okay, it may happen that this j plus x exceeds m, right? So let us consider this case. So there are 5 elements in each row. So your j is suppose 4 in the sum of the iterations, and you perform x is equal to 3. So what element will be at this position when you perform 3 operations? It will be basically 2, right? So it will be basically j plus x percentage m, which is 4 plus 3, 4 plus 3, 7 percentage 5 is 2. So element at the second index in that row would be at this position. So that is why j plus x percentage n, and I am using the one based indexing in my solution. So that is why if j plus x is n, then I will consider it directly as it is. I will not perform the modulo operation. So why is that happening? So suppose here x was 1. So j plus x would have been 5, and 5 percentage 5 is 0. 5 modulo 5 is 0. So we don't want this to happen, right? So we will directly pick this value. So after one rotation, 5 will come here, and we will directly pick that. So that is basically the transition that you need. So let me take this transition. Okay. Okay, what is happening? So basically, let me take these transitions. Okay, why is it not selecting? Yes, it's selected, and yes, we are good to go. So we will try iterating over every I, every j, and every x. Okay, so this is dp of 1, by the way. This is this is also dp of 1. So three-dimensional dp's are dp1 from now on. Okay, makes sense? I think it does. Okay, so this is basically the main transition, And one more thing is that after performing all of this, you have values of dp of 1. Okay, let me write it neatly. So you have values of dp1 of I comma j comma x for every x, right? So you can update your dp of I comma j, right? You will update dp of I comma j, which will be minimum of all the dp1 of I comma j comma x for all x belonging to 0 to m minus 1. So why we need to do that? So basically, when you will calculate the answer for this cell, okay, you will calculate the answer for this cell, then you need to update its dp. So you need to update its dp for the calculation which will be performed for this cell. Okay, for this cell below, value of this thing's dp is needed, right? So the value of the dp based upon which is of this cell is needed for the calculation of answer of this cell. So that's why we have to update our dp of I comma j instantaneously when you calculate the all of the values for dp of 1 comma I comma j. Okay, makes sense? I think it does. Okay, so and one more thing. Okay, so okay, wait, let us directly head to the code to understand it in the better way. So yes, initializing this dp of 1, which is three-dimensional dp, and yes, I'm using this one based indexing. So one more thing is that, so suppose, okay, this is your grid. So suppose this is your grid, and okay, so for these dummy cells which are of zero based indexes, so what I will try to do for them is that I will assign them L long max based values, order of L long max, order of the values. Okay, so that is basically what I'll do to avoid any wrong values which can appear here. Okay, so when you are trying to perform these dp1 of I comma j comma x operation on this cell, it you basically index j minus 1. So you're trying to access this cell. Okay, but this cell has to be the much larger value because you cannot reach there, right? So something practically of the order of the infinity based upon the constraints of the problem. Okay, so that is basically the thing. And yes, that is for the columns. For the first column, zero based column, you would say, and this is for the zero based row. Okay, this is for the zero based row. So one more thing to notice here is that, so if you are trying to calculate answer for this cell, suppose this cell, then you will access dp of I minus 1 comma j, right? So you will try to access this cell, but it cannot be reached, right? So it should be also of the order infinity, right? So that is why initializing it with the L long max by 2 as well. And yes, initializing dp of I comma j, basically the answer dp with the maximum values possible. Okay, so and for here, so this is one of the most important parts of the solution. So this for loop this for loop is designed to explicitly calculate the dp1 values of cell 1 comma 1 comma x. Okay, so if you try to calculate it normally like this way, then your this value, so then your this value is also infinity, right? So you are trying to calculate the value for this cell, so this value is initialized to infinity and this value is also initialized to infinity. Then minimum of some infinity plus something and something will be of order infinity, right? So infinity and plus some value will add, right? So it will be much bigger value, but it is not the case, right? So it is practically not infinity, right? So for that you have to take care, you have to calculate all the dp1 of 1 comma 1 values separately. Okay, makes sense? Yes, it does. So for that, calculating those values explicitly. Okay, and yes, running the three nested for loops, and if I is equal to 1 or j is equal to 1, you need to basically skip that thing because we have explicitly calculated it here. Yes, and if j plus x percentage m is 0, you won't do percentage here, right? So you don't want to perform percentage here like you have did here, right? Okay, so that we have seen in the solution. And after dp1 of, so after uh, after every value for dp1 of I comma j comma x is calculated, for every I comma j, so all the values related to x are calculated, then you have to update dp of I comma j is equal to minimum of all the dp1 I and j and x over all the x, right? Over all the x belonging to 0 to m minus 1, right? That is basically this for loop doing. Okay, that is basically this for loop doing. And notice carefully that I is going from 1 to m, j is going from 1 to m, but our x is going from 0 to m minus 1. Okay, and yes, finally our answer will be stored at the dp of n comma m, and you will simply output that answer. Okay, makes sense. Okay, I have tried to explain the solution to you in the best way possible that I could do right now. Okay, so sorry if there were any errors or whatever, some discrepancies in the solution. If you found something wrong in the solution, feel free to comment below the video. But yes, thank you, I really appreciate your patience that you are still watching at this point. And yes, thank you for watching the video. Consider liking the video if you learned something new, and consider liking the video, staying subscribed to the channel, staying tuned to the channel. And yes, thank you again. Thank you.